Assalamualaikum. I wish to Madam Farah Wahida binti Azhar and my fellow friends who are watching this video presentation. My name is Nur Farhana Izati binti Zulhaidi.
My name is Nur Aimi Azlin binti Azizul.
My name is Nik Amalindamia binti Nik Rozihain.
My name is Nur Ili Ayuni binti Idris.
My name is Nurain binti Lokman.
My name is Nur Shafika binti Zana Abidin and we are from class CS1124A. Today, we will be discussing about the applications of systems of linear equations in traffic flow.
As we all know, traffic flow is the study of the movement of individual drivers and vehicles between 2 points and the interactions they make with one another. So, in this case, we use a system of linear equation to analyze the flow of traffic for a network of 5 one-way streets to ensure the efficiency of traffic flow of the road. So, this method is used to determine the number of vehicles that should be allowed to route the 5 one-way streets in order to keep the traffic flowing. So, in our case of study, we use the method of Gauss-Jordan elimination to solve the system of linear equation. So, in order to apply the system of linear equation in the traffic flow, first, we need to create a system of linear equation by following two assumptions in order to ensure the smooth flow of the traffic. So, the first assumption is vehicles entering each intersection should always be equal to the number of vehicles leaving the intersection. Second assumption is the streets must all be one-way.
Next, we're moving on to the problem statement. As we already know that traffic congestion and long queues at intersections during peak hours is a very serious problem that we have to deal with in order to achieve smooth traffic flow. Expanding the infrastructure such as widening the road does not enough to handle the smooth of the traffic due to the increase in traffic demand. Inability of existing method in determining the traffic demand and provide suitable time split when the traffic volume exceeds its capacity is another main factor which leads to traffic congestion. This problem arises due to poor coordination. Therefore, in this case study, we will calculate the flow rate of cars on each segment of the street to reduce the traffic jam.
Now, I would like to talk about objectives that we obtained from this study. Before that, the purpose of this study is to determine best ways to achieve smooth traffic flow at the intersection. First thing is, we identify some problems that cause traffic jam at intersection during peak hours. As you can see, there are many private vehicles on the road blocking one another until they cannot move because they move at the same times of day. This can be shown when people are going to work or school in the morning, also in the evening when they want to go back home. Next, we move on to second objective, which is reduce traffic jam. There are a lot of ways to avoid this thing happen, such as minimize the number of car use. Other than that, we can ride a bus or monorail to avoid traffic jam. And also, it can make it easier for us to reach our destination at the right time and to meet our beloved one safely. From that, we can create a flow in and flow out is equivalent. And the last one is we apply solving system of linear equation that involve Gaussian elimination method and Gauss-Jordan elimination method. By this calculation, we be able to calculate the flow rate of vehicles on the road. Then, the flow in and flow out of the vehicles is equivalent can be shown. This will be explained later by Farhana and Damia.
First of all, I want to inform that there are two parts in this section. So for the first part, I started by showing the diagram. As you already know, this is a network of one-way streets. There is a guide which you can refer to for more understanding on this diagram. Based on the diagram above, we can see that there are 88 cars per hour traveling on the street leading to intersection A. 74 cars per hour on the street joining the intersection C and D. 45 cars per hour on the street joining the intersection D and B. 56 cars per hour on the street joining intersection C and B. And lastly, 120 cars per hour on the street exiting from the intersection B. First and foremost, based on the problem statement and observation, the total flows of the traffic in and out must be equal. As you can see, there are two streets with the blue that leading into the network. First, the street leading to intersection A brings 88 cars per hour. And the other street leading to intersection C brings X3 cars per hour. This means that 88 plus X3 cars per hour entering the network. Next, as you can see that there are also two streets but with orange colors that are leaving the network. First, the street leaving from intersection B brings 120 cars per hour. This means that altogether 120 plus X4 cars per hour leaving the network. So here, I will explain to you about the situation happened by each intersection. At intersection A, there is only one street going in and this street brings 88 cars per hour. Throughout the time, there are two streets going out and total flow out is X1 plus X2 cars per hour. Besides, at intersection B, there are three streets going in and total flow in of this intersection is X1 plus 56 plus 45 cars per hour. During the time, there is only one street going out and this street brings 120 cars per hour. We continued to the next, where at intersection C, two streets are going in and total flow in of this intersection is X2 plus X3 cars per hour. In the meantime, there are also two streets going out and total flow out of this intersection is 56 plus 74 cars per hour. Lastly, at intersection D, the flow in goes along the single street that is 74 cars per hour. At the same time, there are two streets going out and total flow out of this intersection is 45 plus X4 cars per hour. This table is constructed based on my explanation just now. It is like a summary for you to understand easily the situation before we move on to the part 2, which is solving this problem by using reduced row echelon form RREM. But before that, we must arrange all the variables to the left hand side and the numbers of cars per hour at each intersection to the right hand side.
So now we are going to represent the system of linear equation in the form of augmented matrix. So now look at the augmented matrix. The value on your left is for variables and the value on your right is for constant. Since we already have determined the augmented matrix, now we are going to solve it using reduced row echelon method. Firstly, we need to make sure that the entry in the first row and column is 1, or we call it leading 1. Therefore, we will exchange row 1 with other row that have leading 1 in the first column. In this case, I'm going to exchange the first row with the third row. Because we are using reduced row echelon method, all the entries below and above the leading one must be 0. As you can see that below the leading one in the first row is also 1. So we need to change it to 0. In this case, I'm going to multiply the first row with negative 1 and adding it to the second row. Thus, we will have new R2. Since all the entries below the leading one in first row is now 0, we will move to the second row. So in second row, we can see that there is already leading 1, but below the leading one there is another value of 1. So we need to change it to 0. Therefore, we need to multiply the second row with negative 1 and adding it to the fourth row. Now, all the entries below it are zeros. Now we move to the third row. We can see that there is leading 1 there. Thus, we need to make sure that all below the leading 1 is 0. Therefore, I'm going to use the same method, which is multiplying the third row with negative 1 and adding it to the fourth row. Now, all the entries below it has become to 0. Next, we move to the fourth row. We can see that there is leading 1 in the fourth row. As what I said, all value below leading 1 must be 0. So I'm going to multiply the fourth row with negative 1 and add it to the fifth row. Because we are using reduced row echelon method, we need to make sure that all the value below and above the leading 1 is 0. So as we can see that there is negative 1 in row 3 above the leading 1 in row 4. Therefore, I'm going to add row 3 with row 4 to eliminate the negative 1 and change it to 0. Now we have finished doing the reduced row echelon method. Thus, we can now determine the value of all the variables. Each column represents each variable. Column 1 represents x1, column 2 represents x2, column 3 represents x3, and column 4 represents x4. From the first row of the matrix, we get that x1 is equal to 19. And from the second row, we get that the value of x2 is 69. And from the third row, we get that x3 equal to 61. And the fourth row, we get that x4 equal to 29. So now we can substitute the value of all the variables that we get into each row. We get that the value of cars flow in at each intersection equals to the cars that flow out from that intersection. Thus, there will be no traffic problems.
Alright, so we go to the conclusions. Okay, the problem in our case study is to find the flow rate of the car on each segment of the street. For example, the common things that we can see at the city, every people who live in the city will be face the same problem, such as traffic jam during the peak hour. So, we all decided to use solving linear equation to solve this problem. The reason why we use solving linear equation because we can identify the problems of traffic jam and the queues of intersections during the peak hour. Okay, first thing first, we should to identify the cause of the traffic jam. The second one, we should separate it into the two groups. First is flow into, and the second one is flow up from the intersections per hour. When we separate it into the two groups, we can solving it by using the solving linear equation method. The second one reason we decided to use solving linear equation because in our situation we have many variables and many equations. So the solving linear equation is the best method that we can use to solve this situation. So next, we can set that inside the SLE we also applying the RREM, which is reduced row echelon method. By using reduced row echelon method, we should make sure every top and the bottom one must be equal to 0. Okay, when we get the every top and the bottom one is equal to 0, we can get the accurate amount of car per intersections. For example, we can see from our methodology section before this how the flow our calculations when using solving linear equations and reduced row echelon method. Basically, I can say it, by using RREM, our calculations become more easier. So as a conclusion, we all managed to achieve our objective. So thank you.